Thanks, Ben. So hopefully that was interesting, actually having a deep dive there, looking at the kit. Right, now we're going to move on to the more interesting part of our presentation. We're actually going to start working live on vehicles. First section, diesel diagnostics. So before I start, we're just going to walk you through what we try and do with each of these tests. So we're trying to, first of all, give you information about how you make the connect, because there's going to be really 3 questions you have when you first start with PicoScope and oscilloscope diagnostics. You want to know how to connect to the component. That's point 1. Point 2 is how we run the test. So what condition do we need the vehicle on to capture the data? You know, do we just need the engine running? You know, do we need to do something different to make something action? And then finally, and arguably the most important part of our presentation today, is reading the signal. So once we've got our waveform, how do we understand what's good, what's bad, you know, and where do we go to find more information if we're unsure? And finally, just before I go into that, we should say that it's perfectly safe to use PicoScope, and we're not putting any huge voltage through the accessories from the scope, so you can't fry an ECU, you can't do anything wrong. We'd always advise you, if you're unsure, start from a guided test. It's going to give you the right advice to work on that component, but it really, really is very, very safe to use. Okay, we're going to start at the beginning. We're going to have a look at injector testing here on our beautiful Kabuto digger. And again, what I'm just going to run you through is how we're going to make the connection. So in this case, you know, we've got 3 of our channels used up. So on channel A and channel B, we've just got standard ×1 test leads. And then channel C, we've got our current clamp, in this case a 60 amp current clamp. Okay, so that's our 3 connections into the injector. And in terms of how we run it, 2 things we've got to do. We've got to have the engine running, and part 2, we've got to have the scope started to capture the data. And Ben's going to take you right the way through this on the machine. And this is basically what we're hoping to see. So we've got our 3 channels of data there. You'll soon get used to this, but we have channel A is always blue, channel B is red, and channel C is green. You can change them if you want. We tend to keep them as standard. They work for us and obviously correspond with the test leads. And if you go into the guided test, it's going to give you this information. Yeah, so this is what we expect to see from these 3 channels of data. Yes, we've got our injector voltage, positive and negative side, so 1 and 2 there you can see, and also we can see the current side, so we can see the current draw through the connections. So we can really, really nice detail, and I'm sure Ben, when he zooms it, will show you, but if you see there's a real tiny little hump here. This is just what we call the pintle hump. So we see that as the movement of the needle. So we can see really, really deep detail by getting into the software. And as Ben showed you earlier when he did the little software introduction, being able to use the zoom function, being able to move backwards and forwards through time, really allows you to deep dive into the diagnosis. Okay, well, the moment you've all been waiting for, I'm going to hand you over to Ben now, and he's going to work live on the digger and show you that injector testing. Over to you, Ben.
All right, cheers, John. Okay, so we're going to have a look at some injector testing now. So for what it's worth, they're all pretty straightforward. Most connections are okay. Some of the sort of bigger stuff tends to have a unique plug, which actually gets you inside the head. For this particular engine, obviously being one of the slightly smaller ones, all the injectors are on the top. It looks a bit like a normal diesel engine that you'd see in a car, for example. So connection-wise, all I've got in here is I've actually used a couple of the breakout leads from our universal kit. The main reason is that we don't have one for this particular injector. However, obviously we could have taken some of the insulation off the back of the plug here and actually made a connection there. It's just really to get a better access for the current clamp. Could have backpinned and just that would have been fine as well. Yeah, just to make it a bit easier for us for this test. So the test itself obviously lives within inside the guided test menu. So what we'd go is into the heavy duty section and then find the injector test. Now I know in this particular version they are classed as a unit type injector, However, solenoid injectors kind of follow all the same basic principles. So we could, if we wanted to, just use the standard automotive menu and go to the actuators, diesel, and then solenoid type injector. They're all pretty much the same, all right? So there's nothing real massively different. When we get onto unit injectors, however, they are slightly different in terms of how they're operated, but for this particular vehicle, pretty straightforward. So we have 3 connections. We have the ×1 test lead on channel A going to one side of the injector. Channel B is also going to be a ×1 test lead, and we're going to plug these in as we go. And again, they are literally just connecting to both sides of the injector. Let's get that out. We obviously need a ground reference. Now, within the off-highway kit, you do get longer leads, so we may be able to get round to the battery, and on the battery negative, that's kind of best practice if you can. You might find that the grounds on a lot of off-highway equipment is particularly noisy. So with some tests, as we'll see a bit later, it's sometimes useful to use the sensor ground as well. However, for this injector, obviously we're just going to look at both sides from a voltage point of view. So ×1 test lead on one side, and the channel B onto the other side. And as the guided test suggests, it is a free channel capture, so we're going to put current on there as well to give us everything we need to build the picture up about this injector. 50-50 chance of getting that on the right way. I'm guaranteed it's around the wrong way, but the software's got some nice clever features now where we can flick that round without actually having to go back into the engine bay to switch it. So with the guided test, obviously there's lots of information within the guided test. We're not going to go through that. We're just going to minimize all of that, and we have our reference on the screen. Something I would like to point out is I'm just going to disconnect the current clamp, and I'm just going to start the capture. Now obviously probe mismatch is a relatively new thing for PicoScope 7. It only works when the file has been captured using a 4425A scope with BNC+. If that file has been loaded and you try and run the scope and the settings don't match, you will get a probe mismatch warning pop up. And with that in case, obviously I've disconnected the current clamp on channel C. So it said the probe that expected was a BNC plus 60 amp current clamp. It's not been detected. So obviously I need to plug that in and it will let me run the test. Cool, right, there is a trigger on this capture, but as we can see, we're in auto, so that does actually mean it will still show us something until we're ready to actually capture and the trigger settings are met. One quick thing to point out, I've actually used the TA473, which is the slightly more premium clamp that comes with the Elite kit and the Expert kit. If you've got an entry off-highway kit, it is the smaller TA496, but again, it's perfectly suitable for this test. Right, that's everything's set up, so we'll start the engine. Okay, great. Well, I didn't get my current clamp up the wrong way, so that's the main start. What we're going to do is just going to let that settle for a second. Just let that run for a little bit longer. Let's just stop that test and we'll switch it off. Okay. So, from what we've actually already seen, we've got our control, which is on channel B, our supply on channel A, and the amount of current, so the work done. That's kind of arguably the more important thing. Current can show you a lot of information very quickly. One, does it work? Two, is current flowing? So therefore, have we got a voltage differential? Remember, without that, we can't have current flowing. So if we move those two out the way, some important parts of the waveform, let's see what the current draw is for that first injector that we've looked at, where we're looking at 13, nearly 14 amps. If I wanted to, I could now move to another injector. I could take a reference waveform of that, capture it on the screen. So a very quick way of doing a reference waveform. Off the tools, if it's not on tools, click more. References, channel C, and that will now drop a new axis in behind it, where we can actually get a almost like a snapshot or a screenshot of that waveform, and we can move to the next injector and compare the three signals that are coming in. John also mentioned something called the little pintle hump at the end of the the control side of it. So as the injector is switched off, the needle will then move back, so current has stopped flowing. So we can see at this point here on the waveform, that's when our injector is switched off. We get a collapse of that magnetic field, we then get induction, so that causes that voltage spike to occur. And then obviously as the needle then moves and travels back through that coil of wire, it actually makes a slight movement, generates a slight magnetic field, which then generates our electricity, which then gives us a little bump in that signal. So that just tells us that something is moving. All of that stuff is really important in determining what your needle or what your injector health is like. You know, I just mentioned something about voltage differential. So if I look at these two signals, this injector doesn't start at 0. It starts at 6, sort of 7 volts, and you should see that both sides have the same voltage level, give or take. If I got my rulers a bit better, you'd see that. Current is not flowing at this beginning part. So this is almost like a fail-safe that the ECU actually tries to determine whether or not you've got an open circuit. So very, very easy. Is there voltage both sides of it? Yes or no? Great. If there is, then we can actually, if there isn't, sorry, I should say, then we can actually drive the injector, so force one side of it down to ground or as close to, the other side high. In this case, it's getting up to, yeah, about 88 volts. And then obviously current can flow. We have a voltage differential. Very, very quick insight and overview into injector testing. Obviously, things that are in your favor, definitely reference waveforms. Obviously, you've got the waveform library as well. Hopefully, someone's out there has actually already made a known good capture for you. The preset on the guided test, as I said, solenoid injectors, they're all very, very similar. You may find that obviously we have 2 events that have taken place. Here, you may find that sometimes you'll get 3, sometimes 4, sometimes even 5, depending on how the system operates. So finding out what is a known good, very important. Finding out how it works, also important. But obviously getting your captures so that you can refer back to them between cylinders, also really, really useful. All right, I hope that helps. Back to you, John.
Okay, our next test is a Diagnostics evaluation. So similar to before, actually, we've got 3 channels of the scope in operation. We've got channel A and channel B again as just a ×1 test lead. And channel C is our 60 amp current clamp. In terms of how we need to have the system operating to capture this data, so we're going to have the engine started obviously, and we need the Diagnostics unit to be actually supplying pressure to the system. So there are 2 things that we obviously have to have operating, and we are going to capture a waveform that's going to look something like this. And really things to look out for. We expect to see this wave here if we've got a normal operation. So if that was flat, there is probably something wrong. And then more importantly, what we absolutely want to see the minute we turn the ignition off. So this is a capture where we've got the engine running to begin with, but we're going to turn the ignition off because we want to see what happens as the system starts to wind down. And at this moment, as you can see, we expect to see that to drop straight away. So that's our injector controlled, just to prevent any vacuum. So that's really the basics around it. I'm going to pass you back to Ben now, and he's going to talk you through this system and just how we can use PicoScope to look into the detail.
Okay, so we're going to have a look at the Bosch Diagnostics 2.2 AdBlue guided test. Now, the Diagnostics 2.2 is very common on a lot of machinery now, both off-highway, agricultural, HGV, seems to be in everything. It's a very simplistic way of adding an after-treatment system to existing machinery, but there are some very nice common and similarities between all of the systems. So once it's fitted to one, you've got a known good, you can actually apply it to another one. So we've created a guided test for this particular pump, so that's where we're going to start first. So in the heavy duty and off-highway section, we're going to find our Bosch Diagnostics 2.2 system test. Load the guide and settings. That will obviously give you some information about the connection, a sort of what a known good one looks like. Now, I appreciate that there are a number of different tests that you can do in serial diagnostics. The trouble is when you get to things like off-highway, It's not necessarily a one tool fits all, and sometimes you're not able to actually perform a sort of test on the after treatment system. So this basically looks at a couple of inputs. So we are looking at the pressure sensor for the after treatment system. That's the actual pressure sensor inside the pump. The PWM signal that controls the pump speed, and we're also looking at the after treatment injector, which is actually at the outlet of the exhaust system. So if we have our test on the screen, we've got it all set up. It is a long capture. Now the reason being is that what we're going to do is we're going to let the system run up, get to its pressure level, and then obviously watch how the pump controls that input. We'll also see a little activity in the after treatment injector as like a bit of a self-test. What we're looking for is when it creates that or forces the injector to work, we should see a momentary drop in the actual pressure system. Now that indicates that something, or there's been a release of fluid into the exhaust system because the pressure has dropped, and we want to see it recover nicely as well. Once we've seen that activity, we could continue to let the machine run, then ultimately we'll see consistent pulses to actually indicate that it is injecting fluid into the after treatment system. Alternatively, what we can do is once we're happy that we can see that drop, we know that everything's working as it should, then in fact we just switch the machine off, let it go through its purging cycle. Then what it will do is as it gradually gets lower and lower and lower, the system will activate the pump again, switch a valve, so now it's actually returning and pulling the fluid back through the pipework. But what we're also looking for is the moment the injector operates again. Now the reason being is that if we're pulling against a closed system, we're going to start to create a vacuum. In order to prevent that vacuum collapsing the pipework, it will actually operate the injector to induce a little bit of air into the system so that it's got something to actually maintain, not create a complete vacuum within that pipework. So we'll get the test up and running. We'll start the machine. It may take a little while for things to activate, so we'll just keep an eye on it. And then we'll go and start the machine. So hopefully with everything running, there we go. So yeah, control-wise, we're looking at the pressure sensor. We've obviously seen that voltage jump up slightly. We've got some activity on the motor control signal. Now, if we were to zoom in around that a little bit more, it's actually doing something clever with data over PWM. It's a nice little piece on the forum that Steve did about this. Basically, we can get the temperature of the pump across over the PWM signal line. So this may take a little while to get itself warmed up. When it does, we should see that PWM signal change to a more expected behaviour, and we should start to see the pressure signal ramp up. And obviously we're looking at the sort of 4.5 volt to be peak pressure, but somewhere around the 3 volt mark is that sort of 9 bar magic number that we're looking for. Okay, so we've now reached a point where the machine is happy, it's warmed up enough. We've actually got some change in the PWM signal, so you can see it becomes a much thicker block of red. If we were to zoom in there, we'd actually have a consistent or expected PWM signal. You can also see the pump pressure ramp up, so we can see how that's increased. So note that the engine speed's changed slightly as well. Right. This is the important bit now. So we've actually had activity in the injector, and we can see that the pump pressure has momentarily dipped. And that's exactly what we want to see. We want to see activity lined up with when the pump actually, or the after treatment system, activates that AdBlue injector. Happy there it is. I'm going to switch the machine off, and we're just going to watch the purging cycle. So again, this guided test has a trigger, so it's basically watching for the pressure to fall below a certain threshold. In this case, it's set to 2 volts, so once it's past that 2 volt, then we will continue to capture. It's just a way of keeping everything on the screen. Bear in mind that this next section can actually take quite a while for it to actually activate. It may even go onto the next screen. If it does, don't worry about it. We can obviously capture it all in one go. So we'll just keep watching, and eventually what should happen is the pump will kick back in, and we should see the activity from the after treatment injector to prevent that collapsing of the pipework. So again, this may take a while. Okay, so we flicked on to the next buffer, which isn't a problem because we're still recording. We have got a long enough time base as well, so it doesn't matter that we're not going to hit the trigger. What we're looking for is this point here. So we can see how the voltage or the pressure signal has dropped. The pump has kicked in, but before it goes too low, it automatically activates that after treatment injector. So again, this is just the purging cycle. It's just going to keep pulling that fluid back into the after treatment tank. And obviously, one of the main reasons for that is to prevent freezing. Diesel exhaust fluid, or AdBlue, however you want to call it, freezes at about -11 degrees. It has a high concentration of water in it. Therefore, it starts to freeze, crystallize, and we get all sorts of problems. So obviously, pulling that fluid back is really important. So as I said, inside the pump, it's actually just a little valve, switches over. The pump's still turning in the same direction. We're just drawing the fluid in from a different way. And we should see is once that's all happy, it will complete the test, and we're happy that everything is as it should be. And there we go. It's just literally finished just before we reach that trigger, so that's good. Interestingly, the after treatment injector is still active at the moment. So we'll just wait for that to stop. But realistically, all the information that we need is on the screen at the moment. So again, the important parts here, we look at where that voltage dropped from that pressure sensor, and just as the injector cut in was around about the minimum point that pressure sensor got to. So the pump or the after treatment ECU is watching for that signal to drop to a certain voltage. If it gets to there, then it will automatically fire the injector. If at this point we still continue to see a sort of falling voltage, it could indicate that there is a blockage somewhere in the line. All right, so there's a lot of information that you can get from this simple little test. All right, thanks for watching.